Hello everyone, welcome to my another video. So today again we will be solving another problem from Leetcode which is related to binary tree concept. So you'll get idea how we solve using different traversal algorithm along with their usage and all other things. Let me just pull this on the left hand side. Let's understand the problem first, then we will switch to the programming. In case I couldn't finish this in 15 minutes, I'll create another video for programming. This is just explanation. So yeah, let's get started. Here if you see, we will be given a binary tree and we have to find out longest path in case we remove any of the edge or any of the node from the tree. So here if you see in the example, we have given this tree, and if we remove this node 4 from the tree, then in the remaining tree we just have to find out the longest path, and that we have to return as an answer. So let's take the example of input we have given. So this is all the node in the above tree we have given, and we will be given another array which is the input from which we have to remove the node. So this array is to denote the number of node we have to remove. So for example, if I want to remove 4, then this will be the remaining tree. Here if you see, here there are multiple queries has been given. So first I want to remove 3, then in the second iteration, it's not in the single answer itself we have to remove all these are all unrelated. Like first I want to remove 3, then after removing of 3, what is the longest length? This is 4, I mean 3 is the longest length, right? I mean this node until then. After removing 2 in the second iteration, just forget about 3 now. Second iteration, if I remove 2, then what is the longest path? That we have to find out, which is either this or either this, right? So that's what we have to get into the answer while solving this problem. Now how we can solve this problem? We will be having two basic algorithm. One is by breadth first search, BFS. Another one is depth first search, DFS. Last time I have explained breadth first search in my last video. So today we will be creating another problem here with the help of DFS. So you will get idea about that algorithm as well. So yes, let me try to explain how our problem will be relatable with DFS. So here what we have to do, for example, I want to remove 3. Okay. Now let's see. I'm not removing or anything at first. I'm just doing some DFS traversal, and additional to that, I'm tracking how many levels we will be having in the place of 3. If I try to remove this 3, then I should know before that itself how many remaining longest length present currently, right? So while doing traversal, I'm keeping the track of all those values. So in case I want to remove something, I'll have everything in hand. So let's see. I am starting from here. You can start from any number of node, but I am starting from 1. Let's consider this is my root node. Okay. Now, if my DFS is starting from root equal to 1, so I'll just give my method as called DFS, where my root equal to 1, and second number is I have to pass the level. So initially, as I'm starting for the first time, my level will be 0, right? So this is level 0. Now second thing is what I will need to check is there is any other root present, or my tree is entirely null. So that will be the first condition when I'm checking my DFS, right? So in DFS I'll have to check if my root itself null, then do return from here itself. Okay. If it is not null, then I'll proceed to its left and right child simultaneously. So now let's see, before I go into the depth of root node, I will first keep a track of two variables. One is max level, and another one is max count. So max count is my matrix, and I'll define it as a global variable for this matrix as well and for this variable as well. So I will define it class level. So whenever I'm going inside the method, it value will gonna kept as it is until we um I mean traverse whole graph. Okay, so initially what I'll do, I'll say my root dot val it means ki whenever in Java whenever we create any integer array or any 1D or 2D array, initially it's all values get assigned to by default it is 0. So by default it was 0 before this root.val. It means, let's see, this is the array of max count, and initially it was I am having here 5 node, so there will be 0 0 0 0 0. So it will be initially 0. Now what I am doing, I am just checking, I am just assigning max level, whichever is max level value. By default if I say it is always 0, so I'm gonna assign just a max level, and my max level will be just finding out whichever is maximum of the current max level, because I just want to find out maximum level at which we are present right now. So it will be finding out maximum level between my this current level, which is by default 0, and the level we got while calling this DFS. Okay, so by default when we started it was 0, and by default max level as well we kept 0, so there will be no value getting changed while solving the root node. So what next? Next we have to go in the depth. So while going into depth, we will be having left child and right child, right? So first if I want to go to the left, and the level will be +1 every time we call its child. Now what gonna happen? We just going left left left. It's not like that. Let's see. In DFS, whenever we hit any of the child, for example, we are going here, okay, and every time we have to assign these two values. One is max count, which will be here as well. In the second time my max level will be 0, okay, because max level is getting assigned in the next line, right? And my max line will be 1 because the maximum of this 0 and 1 is 1. So here my this is max count is 0 and my max level is 1. Now what it gonna do in the next iteration, when it call itself, right? It's calling itself again here. It will count its level and count, but next it gonna check again, does it have any left child? Because after entering into recursion it calls until and again we got return, that means there is no child available. It gonna call itself again and again. So it will go to its left, is there child available? Yes it is. So it gonna calculate again here. Here we have, while we are calling the DFS, we gonna do level +1 each time. So while calling itself it was 4 comma the level was 2, right? Now 4 comma level was 2, when calling its max count and max level, what it is, max count was already no, max level was already 1 in the past iteration. So it gonna say the max level gonna assign to max count, which was 1, and the max level again the maximum 1 and 2. Previous value was 1 max level and current level is 2, which was at the time of calling the DFS. So maximum of 1 and 2 is 2. So this is my max count and second is my max level while calling this 4. Now we have to iterate its right child as well. We have called here root dot left. What about root dot right, right? So I'm gonna do right here itself, and this is also level plus one. Now let's see when it comes back to its like we got return here because there is no child available at after the 4, so we're gonna return at 2 again back. After coming back, as we added right here, so it gonna iterate same thing to here. Here as well again it was the past value of before. What value of max count was? Max count was 1 and max level was 2. Now it gonna assign max count as a max level, but max level was 2, right? So now if we compute this as 2 and max level was 2 itself, because 2 maximum of 2 and 2 is 2 itself. So this is what happened. You'll get to understand this slowly. If you check it thoroughly, what just happened is that in case we deleted this node 5, we know that this max count is 2. That means the current maximum path from the root node is 2. If you see, these and this is 2 only. So if we delete 5, what will be the maximum path? It is 2. And what is the value of max count? It is 2. So while computing, this is the logic we have used. While computing DFS itself, we are tracking the values of each and every node. We are doing this 2 times. We gonna create one function for DFS, right? Here we gonna do DFS, right? And same thing we gonna do for DFS left as well. But while calling, make sure which one you calling first, because in the second one, for example, first I'm calling DFS right, but in DFS left I will have to count the maximum of both. I cannot directly just blindly assign the max level to itself. Here as well I will have to find out math.max, and which is maximum till now we got will be our answer for max count. So here I will have to count that maximum of my previous value, comma, max level. Whichever is maximum, assign it, because I want the maximum level. Our answer gonna stored here itself. Like whichever node there is in the query, we just have to fetch it, and whatever max count is present, that will be our answer. I hope you understand this. So that's all the explanation of height binary tree subtree removal queries. In the next video we will be solving the program. How, like, this is only the program I'm gonna copy paste. I just have to write out additional logic to create, and how we gonna create class level and all. But yeah, let's see in the next video. Thank you.